When we want to use Python and C together, there's a few existing ways to do that. One very common way is through Cython, a library that lets you write type-decorated Python and compile it to C. But recently, a new project appeared called PythoC, which takes a totally different approach. PythoC lets you write Python that generates C code, but more for the sake of writing standalone C programs using Python syntax. Cython's main aim is to write C extension modules for Python, which you can just import as if they were regular Python modules. But PythoC is much less about that. It's more about using Python's dynamism and runtime behaviors as a powerful code generation system for C programs. Now, if all this sounds a little confusing, let's take a look at PythoC in action so you can see for yourself and understand better. This is a super simple example of a PythoC Hello World program. It uses two key imports from the PythoC library, the i32 type and the compile decorator. When we use i32 as our type decoration for this function and indicate that it's to be compiled, PythoC will compile it to a library behind the scenes. We then evoke it by calling the function from within Python. Now, there's one downside to doing this, which is that the C code will get recompiled every single time we run this program. It doesn't get cached and reused the way Cython might do it. So that makes it less useful for integrating C directly with Python. But again, that's not currently one of PythoC's big aims. It's meant to be a code generation system that uses Python to do the work. Let's take a look at another example. This one generates a full standalone C program. And you'll notice that we have two new things here to do this. The first is a main function that has a type signature similar to the main function from a regular C program. The other thing is the compile to executable function, which does exactly what you think. So let's trace all this from top to bottom. We have the imports, we have two decorated functions that generate C code, and then we have the block at the bottom that writes all of the generated C code out as a single executable. So the output of this program when we run it is going to be a build executable program in the build subdirectory. So if we run that generated program from the command line, we get an output. Now, let's say we want to perform more dynamic code generation at compile time. Here's an example of how that might work with PythoC, which I've adapted from their documentation. This function makePoint generates two C items, a structure called point, which we define by way of a decorated class, and a function called addPoints. Now, when we invoke this function, we pass it a type, and the resulting structure and function are specialized to use that type. This suffix parameter in the decorators, by the way, alters the name of the generated object in C to use the type as a suffix. So we'll get point i32 and point f64 as shown down here. In short, we're using Python's dynamism to create what amounts to generics in C. One other thing worth showing is how PythoC gives you techniques to add layers of type-based compile time memory safety to the C code that you generate. Common issue with C that we all know about is not freeing allocations or attempting to use memory that's already freed. PythoC offers a way to perform compile time checking to avoid those problems. So for instance, the linear import here lets you generate a value called a proof, which usually accompanies a memory allocation. The proof has to be consumed when the same allocation is deallocated. So if you don't have a matching consume proof for each proof generated by a linear, the PythoC compiler will generate a compile time error. It will flag this at compile time, not runtime. So this example, which I took from the documentation, shows how you can create simple lmalloc or lfree functions to allocate and free memory safely according to this paradigm. Now, you can always do the allocations and frees manually, but having a compile time, code generated, and type controlled way to do this can save you some trouble. Again, the main point I want to make about PythoC is it's not, at least not so far, intended to replace Cython. Cython is for when you want to write C that's closely integrated with Python. PythoC is intended to let you write C code by using Python as a higher level code generation system, essentially a kind of fancy macro system. The generated code isn't intended to automatically integrate with Python, and the tooling isn't really there on PythoC's side to make that happen. But it wouldn't be impossible to add that in time as another way to make it immediately useful to Python users who want to integrate C. So I'm really curious to see which directions this project takes, but for now you can try it out, although I don't recommend using it in production. And that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and InfoWorld.com.